Alright, making a video. That's actually how I start the original video, which I have to briefly edit, so I figure I'll do it this way, just to show I can play videos, as well as, do lots of other things, so I just thought I would do that. Alright, making a video, I think. Yeah, it's a whole different format, trying something different. So I'm running this on Knoppix. I think that's what it's called. Anyway, it's kind of an interesting Linux distribution that runs kind of fast and simple. It does eventually crash on this computer, but so does Mint. So it doesn't matter too much. So using the webcam mic and those. So obviously it does matter. I wish I could figure out why. It's after like a few hours, like 5 hours or so, and all of a sudden crash. So I'm sort of due, actually, right in the middle of this video for it to crash, but we'll see. See what happens. Crappy resolution on this camera, so I have to plug in a better camera. So I'm really just testing this screen share. So this does have features that I don't like gimmicks, but I really do like this. Yeah, I like this rotating desktops thing. It's kind of neat. So anyway, so I did make a little HTML script so I can open my camera in browser windows and do that conveniently. So I'm working on that. And so this is the Bill Gates and Son, and they're pretty good conversations. I've mentioned it before. I'll post a link. They're just talking about some of the complexity of just, science is a nice word, but it really doesn't mean anything, and just like logic doesn't mean anything. In the sense you have to set up some sort of standard, and this idea of beyond a reasonable doubt, even in an environment full of unreasonable people, that doesn't even mean anything. So maybe I'll speed this up, actually. I should be able to do that. Yeah, I should be able to. Oh, it's not here. I thought it would be playback. Here it is. Okay, speed. So we'll just go faster and hope it's just a little bit faster. And such. So anyway, yeah, so the conversation is, this whole idea of can we demand other people to be rational or reasonable or logical? And I sort of say that part of me wants to say that it's really, life is stupid as it is for lots of reasons, but it just becomes ludicrously stupid if we're not going to fight for any standard of rationality. Like, you can just deny anything or everything, which is pretty much where we are. People can just deny everything. I don't like they don't like the word proof. I think it's a word of a standard, and there's got to be some, some reasonableness in terms of some logical standard for when somebody's being belligerently denying a truth, let's say, evading it. Where it has been established that the one pile of evidence is just so much bigger than the other pile of evidence, and there's no room for pretending there's some hope. But I guess that's the frailty here, is that there is this hope, because we see in the universe that preposterously unlikely things can happen, and so that makes it possible to always hold out for some bizarre explanation, like, yes, the universe is a kid's game in some other universe. Our universe is just a matrix inside of an iPad. Some kind of bullshit. No reason to believe it, no evidence indicating it, but it exists as some sort of vague idea of a possibility, because so sort of what I'm saying is, the fact that we can make up stories is such a liability, because let's say if we were more like a computer or something and our objective was the truth, I don't know if there would be any rational process anywhere where the computer would say, well, we need to invent totally stuff that just can't happen, talking bear, wearing hat, smoking cigar, whatever the other, wolf dressed as a grandmother, we'll just make up all kinds of preposterous ways that the reality could be, and say that's part of the logic process, is to
see if you can imagine. But that's sort of the obligation, right? Is to attempt to imagine within a reasonable boundary, and that's the whole definition of what a reasonable boundary of imagination is, because it's very constructive to attempt to imagine possibilities, but it's very destructive if your imagination isn't bound to what's realistically within the realm of even a remote possibility.
We don't have perfect knowledge, complete knowledge, so we're subject to some lack of ability to be perfectly confident. But again, I don't think that breaks a conversation about the difference between reasonable and unreasonable, and recognizing that you can call people who are indecisive when there's no cause to be indecisive, just pretending. They just don't want the truth to be the truth, and they're just evading it by pretending it doesn't have to be true, or it's not necessarily true, when it's the odds are overwhelming, kind of thing. Anyway, so that's an interesting subject in itself. So at some point, I'd like to talk to Bill Gates' son anyway. Because maybe he's salvageable. He might be able to understand that push is the simpler force.
So yeah, so the whole way of having conversation with people is, you really have to limit subjects and just try to, establish the elemental, the fundamental truths. You got to have some kind of ground to build on, and that part seems to be almost impossible to do. Very difficult. Can't find those conversations. It's always got to be the whole package or no package, no story, no argument, no trial. You can't have a trial just on the pieces of evidence, and maybe that's what it should be first. The trial should be about each piece of evidence and does it have any integrity, and then move on to the real trial.
Yes, the father does seem lost and unreclamatable. But anyway, it's just too bad that there isn't more capacity to have conversation. In that vein, the Richie guy, Robert, he made a video saying goodbye physics, and likely my fault in the sense that I was a little harsh. But again, there's an intractable problem there in the sense that our ability to communicate has to be based on some sort of foundation. We don't have any common foundation. So he's convinced that the creation of all these atom smasher particles is real physics, when I'd argue that's the weakest of the weak physics, and very irrelevant to understanding the things that need to be understood correctly, such as gravity and magnetism and electricity. The biggies. You don't need gluons. They're just...
Yeah, so I've sort of made this point over and over, but it's frankly, physics has really fooled people into thinking that somehow this bizarre stuff is the important thing, figuring out whether there's a big bang or not, or whether the universe is expanding, but they're still clueless on why magnets attract and repel. They're no one's asking the right questions anymore. They're not even realizing how bad physics is at doing anything that has anything to do with stuff happening around us all the time.
It's not going to be role players, so who cares? But anyway, so it's very hard to have conversation, or to just not happen. Just nothing to work with. So I'm stuck making videos like this. So I really should just make a separate Linux video. But the other thing that's kind of cool is I did some of this wine stuff where you can run Windows programs in the Linux distribution. It works on this really simple version, which is nice. And this is an old Windows program. I used to use Photo Stacker Pro, it's called. Really simple, but it has lots of Photoshop style, complex functions. You can do the smearing thing and pattern matching.
I guess I should have had something open. It's a little tricky getting the images actually open, because it only likes the old image formats and blah blah blah. But it's once you figure out how to do it, it works pretty well. So I should go to that window actually. Yeah, there it is. So it's just so familiar. I like familiar things. Anyway, continuing.
You can split an image into the 3 different color maps, and a lot of kind of high-end stuff in just kind of a simple program. So it's really nice to have that capacity to do some image manipulation And the program actually, does pretty good. It's certainly better than any of the Linux ones, except for the fanciest one, which requires a learning curve to figure out how you do it. So the thing is, I know how to use this program, so that's why it's nice. Is because knowing how to use a program is, really important. Kind of knowing the difference between, conversations about facts and evidence. So that's something they don't really talk about in that terms, but I think all of this stuff can be talked about in terms of a trial, and that all you're trying to do is have a good trial, good fair fight. You present the evidence and assert whether you've got enough evidence to prove a claim. And, that's all there is to it. It's not much more complicated than that, I don't think. The other subject I thought I would touch on. So I have two thoughts. So first I'll do one on the momentum argument. So let's say, I really just don't know the answers completely. I haven't thought it through enough, though. Just a curiosity if somebody wants to play with the idea. So let's say you're in empty space and no gravity, no bullshit. And you have two mechanisms. You have a half circle, okay, of track, let's say, and you're going to throw whatever round steel balls that'll roll up the track. And so nothing's moving. The little half circle one, the 90-degree turn, is in front of you, and you're going to throw a little ball, and it's going to hit the track and roll up the track and fly out into space. So,
all right. So I'll just say it again. So you have a piece of track in space. You're going to throw a ball with a certain amount of momentum and mass, and it's going to just roll up a track and fly out the other end. It's 90-degree turn. That's it. Just goes in, 90-degree turn, up. What happens to the track? What happens to the ball? And let's say with a minute, little friction is possible. I mean, if there's no friction, you could almost argue that, there's no way to argue around it, that the track wouldn't move at all, because it's only through the friction that you would transfer any momentum. So you can't even make it frictionless, because friction is the mechanism through which momentum is transferred. And as much as people don't think about it that way, that's what actually happens. Momentum is transferred. It's a momentum transfer. Friction isn't just waste or heat. It's a momentum transfer. It's moving stuff. Yeah. Just another thing, I've been alive a long time, been doing a lot of physical things, and it never occurred to me to understand. I mean, no one said it, so I didn't think of it in those terms, but yeah, it's a momentum transfer. It's not waste. It's not all these things you're taught to think about it as. It's integral to a transfer of momentum. So I can't transfer momentum without friction.
What's the conservation of momentum? What's really going to happen? Is the track going to go down because it's letting something leave up? So you think it has to have some downward pressure, and it's also going to get momentum forward. And what kind of velocity changes are going to happen? So you can't eliminate friction entirely, and that's the trick of it. Because the friction is what converts the energy from one direction to another. So we're back to the spinning wheel argument that got me thinking about all this stuff. And the fact that the bearings are where everything's happening. It's like Ken Wheeler and his gyroscope. Same argument. It's the bearings where the energy transfer is taking place. And it's real energy. It's not just some sort of heat thing. There's real momentum transferring. And that's why gyroscopes will spin. But anyway, so the other part would be is that you have one 90-degree turn.
I'm saying gyroscopes will rotate. It's left sort of as a mystery, but there's no mystery. Is the rotation's happening because there's more friction on one side of the bearing than on the other side, and the momentum exchange is in one direction, primarily. And again, just something no one taught me any of that, and it's just, it's kind of sad that you have to be, nearly 60 years old before you find out, oh, that's why. And it's because you had to figure it out.
So the ball goes in, hits the track, goes out, and which way does the track go, which way does the ball go, and what's the speeds? And then the other one would be you have a loop. Okay, so the ball goes in, goes through the loop, and then pops out. And then a loop where it goes in the loop and it loops back into the loop and it just stays in the loop. So those are two different circumstances. One where the ball goes into the loop and it leaves, and another one the ball goes in and it stays in the loop. And let's say
So I've used this argument before in talking about the drag argument and the complexity of this idea that you can throw something into something and it goes circular, and the circular part can't ever add up to anything. But the part where you initially put the energy in remains. And so in the case of a closed loop where you throw it in, it gets caught in a forever loop, you would imagine the track would have to just keep going. It really wouldn't have an option. It has the momentum that initially went in and the rest of the movement cancels, and so it's stuck with the original momentum until it lets the ball loose, and then it gives back the force. But it has to give the full mass of that ball, and its momentum has to leave for the loop to stop moving. But it's an interesting question about the half loop. What's the consequence? Because you do give it back rather quickly, and any momentum you give the loop is sort of permanent. So the ball has to definitely be decelerated if the loop's going to move. So again, you're back to this friction argument. Without friction, the loop stays where it is. With friction, the loop moves and the ball goes out slower.
Hey, as frictionless as possible, so it can loop for quite a long time. What happens to the momentum? Does the one with the loop where it keeps looping, does that one keep moving forward? Obviously, the one where it loops once and comes back out, you could argue that things can't move very far. It's going to move a certain distance and then stop, as it gave back as much as it took in. So it's an interesting question, because it would seem kind of silly that the one that takes the 90-degree turn keeps moving in the new direction, and the one that feeds it back 180, a full 360, well, full 180, that one stops moving. Interesting. So like I said, this is...
So the other part to that would be, considering, like, as a fundamental argument, what do other people think photons are? Do they think they have perpetual energy? That is, that photons aren't really destroyed. They go into matter and they have to come out of matter eventually. That the energy, the little ball, the little whatever it is, the compression, has to be somewhere all the time. You can turn it into another form, you might argue, reconfigure it, but that whatever it is, like I said, I'm trying to be generous in saying, okay, let's say it, like, you're right, there's an ether and there's a compression. Well, the amount of compression is momentum, and you can't really destroy that, right? So even if you made it into little pieces, particles, what's the difference? You're just talking about a hunk of momentum that can't be destroyed, and that, in a sense, that it's perpetual, because it'll never die. You can never just consume it somehow. You can't make the momentum crash into the momentum and there's no momentum anymore. There's no annihilation events. So I guess that would be a good subject. Do you actually think energy can be destroyed, that it can't actually annihilate in any real sense of the word annihilate? And I would argue no. And once you recognize that truth, then everything sort of, yeah, it starts to make sense, because you just follow the momentum. There's nothing else to follow here except the momentum. Keep it simple. Stupid.
All part of the drag conversation, but it's just part of that argument. It's sort of an interesting to think about. Alright, so the last part of this video, I wanted to talk a little bit about relativity and Einstein's bent time part, space-time. And do a little critique of the, at the end of this video they mentioned they saw the movie Interstellar. They didn't really insult the movie in any way. They just said, well, we found out what relativity means by watching this movie, and it's such a bad movie, because it's so misleading. It's such bad physics. And it's just funny that the guy who was the consultant on that horrible, bad physics movie gets a Nobel Prize, right, for finding gravity waves that nobody really knows if that's what they heard. No real evidence, hard evidence. Anyway, no way to corroborate it, no way to have multiple avenues for evidence confirming. It's just what they say. We've done it. They say so. Period. Pretty much.
Right. So the movie Interstellar is what I was talking about. How I think it's garbage as physics, and it's surprising how few have been critical. Like even the people who know that it's all garbage apparently think it's fun garbage, and so that's okay, and that you're not hurting physics or hurting human intelligence or damaging civilization in some way by promoting something that's just plain wrong, really wrong. So I'm going to switch this around, because you don't really need this part anyway, but I'll throw it in for free. Yeah, what the hell.
Probably should have done a different angle. What is the
hey,
angle?
cool.
So you have to deal with it.
It's totally broken. That's pretty neat.
See how it turns out. All right, so in the two relativity theories, one's about velocity and one's about the acceleration caused by gravity. And most people just say gravity. They don't say acceleration caused by gravity, having anything to do with the time dilation element. So they just sort of think that it just matters that you're in gravity, and therefore you're automatically time dilated because you're in something called gravity.
Probably shouldn't have talked over myself. But anyway, so yeah, we're talking about relativity, two relativity theories. They're basically velocity theories. One is about velocity overtly, and the other one's about acceleration overtly in a sense. Or one's about acceleration overtly, and then one's about, well, the acceleration is assumed to be from gravity. Yeah, so there's no way to make sense out of it. It's about velocity, and people keep thinking this bent space-time thing has something to do with just gravity and how close you are, or how close you are to a planet rather than or to a sun or to some other thing that has gravity, and not about the actual acceleration that is causing you to have an impact from the gravity. There's no impact from the gravity if you're not accelerating. So again, if I put two bodies next to each other and you're right in the middle, equal masses, you won't feel any gravity, you won't accelerate. So you can't be time dilated. See, by the way they've left it open to just being gravity or bent space, theoretically you could put like 7 really dense objects equal distance from each other, and then you could sit in between the middle of them and somehow be so incredibly time dilated, that that 1 minute for you is 7 million years for the rest of the universe. Now that doesn't make any sense, right? Logically, you say, no, that's not the way it's going to work. You have to be accelerated. You have to be actually moved by the force, and it's the velocity that's really causing the time dilation. That's what's screwing the thing up, and you can feel that. You know that if I push you too fast, I mean just a couple of G's and already you're in big trouble. You're helpless and smashed into your seat. And I make it 3 or 4 G's and your brain turns into jello. So I mean acceleration's a real thing, and you can't pretend you can get to a velocity for free. You can't jump from a frame and all of a sudden be going 3/4 of the speed of light, and yet you never had to accelerate to do it. And that's the movie has that all over the place. Somehow people are jumping from all these time frames, and they don't have to accelerate to do it. They don't have to accelerate to go from one speed to another or decelerate. They don't have to go through any of this hard, difficult process of being smashed and crushed. So it's just totally wrong. It's just really bad physics. And people believe this crap. So again, they keep thinking it's gravity, period, without understanding, no, it's acceleration. And as Einstein pointed out, all acceleration is the same, whether it's acceleration from gravity or acceleration from a space elevator, it doesn't matter. It's all the same. And that's what's causing the time dilation, is the movement. Movement causes the clocks to break. Clearly.
The closer you are to the gravitational body, the more you're being affected, and it wouldn't matter if you're actually being accelerated or not. Because that's sort of what the movie relied on, right? Is this notion that somehow you could be in between two gravitational fields, a black hole and then the gravity of a planet, and that somehow both of them could be accelerating you in any kind of real terms. So it's like being halfway, more than halfway, obviously, to the moon. And you get to some point where the moon's attraction is the same as the Earth's attraction, and so you're in a place where you have no gravity, zero gravity. By their arguments, they're sort of implying that you can count the acceleration towards the moon and the acceleration towards the Earth as your time dilation. So in spite of the fact that there's nothing moving you, that you in fact are not accelerating, you're not putting holes in the ground.
Yeah, the simple argument is there's no, you can find out that you're not being accelerated because you can put almost anything there, and there's no way you're going to dent it because you're not moving relative to it. You're both not moving. There's no acceleration. You're not getting closer or further away from either one of the things. So you're obviously not moving because of the thing. So how could you possibly be dilated in that circumstance? And essentially that was the game the movie was playing, was sort of pretending that somehow there would be an equalization of the gravity between the planet and the black hole, and that somehow you could be on the surface and not feel it. But the waves that are 900 feet tall, they're somehow feeling it. So I go into how bad the wave argument. I mean, it's just ludicrous physics. And again, they gave the guy who made up this silly story the Nobel Prize. for gravity waves, which again I would argue is weak physics. But that's the state of physics. This is junk science. I'm sorry, it's just junk.
Impressions. See, we can see our acceleration because we can see our body denting things. So we know we have to be moving. But there's nothing, if I put something there for you to dent, you can't dent it with zero gravity. You wouldn't be able to do any denting. So you don't have any movement. You don't have any acceleration. And so that's a real deception to play this game, that because I'm somehow in between the two gravities, I don't have to worry about accelerating to have my time dilation. I can have both. I can get away with being in zero gravity and pretend that if I put enough bodies around me, enough gravitational influences, that somehow all of them are affecting me and accelerating me at their full capacity if the other bodies weren't there, and that somehow I'm really being accelerated when I'm not.
So again, I just keep pointing out, you know, there's a logical paradox in this notion that somehow you could create more time dilation by creating non-existent acceleration but intense gravitational complexity. So somehow if I just have enough gravitational complexity, I'll still have my time dilation, but I don't have to accelerate. And I think most sensible people would concede that can't be how it works. The component that is important is not the gravity, it's the acceleration caused by the gravity. And Einstein pretty clearly is talking about acceleration and velocity. He's not talking about gravity by itself. He's not talking just about the proximity to a gravitational body, because it matters what else you're in proximity to. It matters.
So it's just pretty much a huge perversion of the truth, because that's, again, I'm arguing that the truth is kind of obvious, that there's nothing special about gravity that bends time. What's bending the time is velocity. And that's confirmed by Einstein's other theory, where he's basically pointing out that that's the mechanism, velocity. So we kind of know that the feature of gravity that's causing any time dilation is the feature of velocity. Right, so the other part that's just kind of bogus about this stupid movie is they give you this idiotic impression that waves would be 10,000 feet tall, okay, on an ocean of foot-deep water would have 900-foot waves, because somehow the water is being gravitationally pulled towards a black hole. And this gets to like the lensing arguments. That's completely backwards, because as the water gets higher, the gravity going down gets weaker. The further away the water gets from the surface, the weaker the gravity gets, and the easier it is for the other body to pull it off. And the higher the waves get, the deeper they are into the strong gravity, and the more likely they are to break off.
So it's just like a fundamental mechanical argument, right? You don't even need a whole bunch of abstract relativity physics or anything like that to understand why mechanically it's just so wrong to imply it's as backwards as using a conventional lens to describe gravitational lensing, because gravity gets stronger in the middle, not weaker, and so it's completely an inverted lens. And the idea of 900-foot waves coming off a planet because they're getting pulled towards a black hole, it would be idiotic to think that as the water gets higher, it gets harder for it to go towards the black hole, when no, the fact is, as soon as it rises anything off the surface, it gets easier for it to rise to the next foot, and it gets even easier for it to rise to the next foot, and there has to be some other force that pulls it back down. So once it starts in a direction, it keeps going in that direction. Obviously, when we start going in a direction, if I jump off my desk and I head in a direction, I end up getting stopped. But once the water starts to rise, because of another gravitational body pulling on it, it gets easier, because as the water rises, it gets closer to the thing pulling it, quote unquote, and further from the thing pulling it down. So the gravity pulling it down is getting weaker, and the gravity pulling it up is getting stronger. So clearly, any water molecule that came any distance, an inch off the surface, the second inch gets even easier. The third inch, it's going to move just like you jumping off of a table. It's not going to be stopped by anything. It's just going to end up going faster and faster and faster, and it's going to go right into the black hole. So it never happened. It's physically impossible. It's a ludicrous example. And what? For visual effects, for more propaganda, more woo, more, oh, it's all so interesting living in a time-warped, blah, 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 blah universe, when they're not accounting for any of the physical realities. It's so far from the truth. It's the opposite of the truth. It's backward to the truth. It's insulting the truth 180 degrees insulting. It's, giving the, talk to my ass. I mean, it's just dissing the truth entirely.
No way that you could form these waves. As soon as the water rises up a little bit towards the other planet, that gravity gets stronger, the other planet's gravity gets weaker, and the water is going to go that way. So it would never stay on the planet. So it's just wrong for them to make this fake circumstance that couldn't exist. And the other problem is they travel from these different frames. I guess people want to use those silly words, from different time dilation frames, and somehow they travel from a very regular frame, fast. Everything's going quite well. We don't have huge velocity because we're not a huge acceleration from any force. And they go from another circumstance where...
So they have the guy back on the ship, right? And the idea is they leave the ship for 1 hour, and that ends up being 26 years. Does that make any sense? No. But the whole point would be is to travel from one frame that's that huge a difference. That means the velocity has to be that big a difference. There has to be that big a difference in acceleration or velocity between this guy and this guy. And they moved between those frames in 2 minutes, 3 minutes. How could you change your velocity from 50 miles an hour to 94% of the speed of light in 2 minutes without it ripping the skin off of you? It's an insane amount of acceleration. I mean, and by insane, I mean ludicrous. I mean, just not even, you can't even come close to imagining what it would be like. I mean, it's only like, what, 4 million Gs? I mean, it's an insane amount of crushing acceleration.
It would require them to have huge velocities, okay, relative velocity. So, and they don't do that through acceleration. They do it in 10 minutes, 5 minutes. They make a 5-minute trip, and somehow in that 5-minute trip, they essentially change the speed they're moving from 50 miles an hour to like 97% of the speed of light.
Yeah, so it's like they're saying it's just really realistically possible to jump from one frame to another, and you don't have to accelerate. You just jump on it like a train's going by, and you just jump on it, and all of a sudden you're going the same speed as a train. You didn't have to accelerate at all. It doesn't happen that way. No reason to think reality works that way. It just can't be more pseudo-science nonsense. I mean, it's flat Earth stupid. The physics is so bad. And again, they gave the Nobel Prize to this asshole.
It's, a huge number, huge acceleration number, huge velocity number. And obviously that doesn't make any sense. You can't accelerate us more than 1 G. You give us 2 or 3 Gs, we're already dead. It doesn't take much to kill us. So how could you do all this accelerating to get to that velocity? And the only way to get to the velocity is to be accelerated. So you have to be accelerated to get to those kinds of speeds. So how could you transition from a zone where you're going 50 miles an hour to a zone where you're going, 2,500,000, whatever meters per second? How can you make those transitions? It'd be impossible for a human body or even physical matter to tolerate the compression that would happen in the crushing velocity and a crushing.
Yeah, so I mean, it's a subject just really somebody should be talking about. But I mean, do people realistically think that that's going to be possible? They realistically don't think, that in the real universe, that there's some place in the universe where you're going to go where you're going to be able to gain acceleration and you won't have to do any accelerating. You just gain the velocity for free. And we'll just pretend that velocity isn't something that changes you. That's why acceleration is so brutal in terms of its damaging to you, is because it's changing you. So you're not staying the same. That's not the process. The process isn't you stay the same and you just end up going faster. No, the process is you change to be going faster. You're physically changed. That's why you keep moving once you get the speed. It's because you were physically changed by the process. You now possess force inside of you, and if you hit something, you'll let all that force loose. And you'll see it when all your little bits go flying all over the frickin' place. You'll see the force that you've absorbed released. How can anybody argue with that truth? That's how it works. When something moves, it gains stuff inside of it, momentum. It's a real thing, and the momentum's going to fly the fuck out if they hit some obstacle that says stop now, that decelerates it quickly. How can somebody argue with that basic physics? Where is there one shred of evidence that the rules somewhere change?
Acceleration. worse than getting hit with a golf club or something. I mean, it's just an insane acceleration that would be required to get you up to that speed that quickly. So there's no way that even if this stupid frame could exist, this preposterous halfway between frame where somehow you get half gravity from one thing and fake gravity. I mean, they're opposite directions. It just can't happen that way.
I mean, yeah. So and then later in the movie, they have all this little dramatic part where the guy has to actually, you have to leave something behind to go forward. Some Newtonian principle. So they didn't give a shit about the Newtonian principles when they're jumping between all these frames. But all of a sudden, later they need Newtonian principles. They have to be obedient to Newtonian principles to gain any velocity. They don't have enough fuel all of a sudden. So they had enough fuel to jump time frames, but they don't have enough fuel, just to not fall into the black hole. I mean, more just bullshit.
So the whole thing is just such garbage. The whole movie was garbage. The very fact the planets couldn't even be round, theoretically, in that heavy and that strong a gravity, the force of gravity on one side of the planet is going to be so much greater than the side closest that it's going to lose its spherical symmetry. There's no way it could maintain it because the gravitational differences will be so great. The acceleration would be so intense it'd have to get ripped to pieces. There's no way it would stay.
Yeah, the planet would be a bunch of rocks. It would be broken into little fractured pieces, and they'd be jiggling around all the time. You wouldn't have a surface per se, and you could just think on every time it rotated, if it rotated, it would end up losing parts of itself because of the imbalances being created in terms of that little extra momentum would just mean that gravity would pull off the pieces as it made the turn. And so every turn it would start losing pieces.
In one piece, it gets spaghettified. So it's like they just ignore their own physics, to play a game, to present a fake world, a bunch of fake notions, in a field that's already confused enough. And this is the part that's really irritating. They're already in enough muddy water, and they just muddied their own water. They're not just like they pooed in their own bathwater here. They have a chance to try to make some assertions and to clarify and to make something understandable, and all they did was create more fog and nonsense. And nobody critiqued.
Yeah, I mean, it might as well have not been made by a physicist. It might as well have been made by somebody who doesn't care about the truth and wants to just invent fake magical forces and whatnot because it's just as wrong. And they're pretending because they had a slide rule in the movie somewhere, or somebody did some math, or they pretended to be scientists that somehow they were doing science, and none of it is science-based. I mean, the whole idea of the premise of it, the gravity problem, so we can make a giant cement, we figured out the quantum mechanical magical trick that allows us to just levitate the Empire State Building and turn it into a magical ship that doesn't need any fuel, and it can go all the way to Saturn without any fuel. I mean, just complete nonsense.
So nobody criticizes this. It's just horrible, really bad for science, bad. Just, this is pseudoscience. It's not real. It's just garbage. It's not by any kind of book. It's not by what they even know to be true. And sort of, what, for money they do it? What's the cause? Why do they have so little integrity as scientists? It's physics is supposed to be their subject. They're doctors in it, and yet they talk absolute shit. They know can't be true, and they make a creative product that's just full of misinformation about their own subject. They slander their own subject with nonsense.
And in an environment where there is so much bad science, in an environment where there's all these people claiming that we didn't land on the moon and this didn't happen, all this the electric universe trying to turn physics into Genesis. I mean, it's just so bad, and they have an opportunity to make some things clear, and no, they just pollute the water some more with fantasies. Nobel Prize.
And again, like I said, there's just too few who recognize it. I mean, it's sad to say that there's so few who are capable of understanding. Oh, that's right. If you're in zero gravity, that means you do have zero acceleration. Just as a practical matter, in a sense, gravity is a negative force. That is, it's the absence of force. You do get pushed onto surfaces. You don't get pulled onto them, and there would be more force going through you.
So again, it's not really the force that's the problem. It's how big an imbalance you're in. So it's just about the imbalance in the force. That's what moves you one way or the other way, and that's what accelerates you, is how much imbalance there is. And clearly, we don't tolerate huge accelerations. And we can't be in a field that's got a huge acceleration and survive in any kind of physical form.
In in empty, perfectly empty space, that is no material objects around you, is where you're under the most intense pressure. But the fact that it is perfectly balanced means it's not going to accelerate you. It's only the imbalances that accelerate you. And it's the acceleration is the hard part of velocity, obviously. And that's the part they totally ignored.
Yeah, I said hard part of velocity. So it's the velocity part that's really Einstein's theories are about two forms of velocity. Velocity, that is the velocity you've gotten after you accelerate, and acceleration. Those are what the two theories are really about. That's what causes the time dilation, and it's just really measuring your real velocity versus your perceived velocity, in the sense that, again, I clearly am going around on the surface of the Earth as the Earth rotates, but I'm even more clearly, I'd argue, clearly going down into the Earth, and then somehow the Earth pushes me back up and I go down and it pushes me back up, and that's what's happening. It's a real thing. So I'm doing this, obviously, and I'm also doing this, and if you put this and that together, you get this longer line that my junk is actually traveling.
All of a sudden we can gain velocity without any work. So the key point would be, if you want to contend something, I don't think there's any evidence they can demonstrate, anyone can show any reason to believe that gravity creates time dilation through any other mechanism than acceleration. Gravity causes acceleration, acceleration causes velocity, and velocity causes time dilation.
Right. So is there anybody who wants to dispute that and say that you could be between two gravitational bodies, equal bodies, and you're in the zero gravity point, and in that point you're actually time dilated because you're getting pulled by both objects? Pulled, quote unquote. Do you believe that? Can you defend that with some reasoning?
As I said, you can almost think of it as a temperature issue. The faster you go going, the colder you get. That's another way to say that. Maybe just because of the imbalance, but it's probably not. It's sort of an inverted analogy. I'm just trying to think if there's a better way to analogize the idea that.
See, it would be better if heat and cold meant that things were jiggled, because that's sort of what velocity is doing. Is it's creating a lot of noise inside of your systems, and that noise is what's breaking the clock. But it's sort of the opposite analogy, in that cold creates less noise. But the truth is that cold is easy to associate with the idea of slow moving and retardation of movement. So it's not the perfect analogy.
Well, as I put it before, obviously velocity is something your body has to possess, the force you're occupied by, and the more of that you're occupied by, the more you're not going to be doing what you were doing before, because most of your matter is busy going somewhere, getting pushed somewhere. So it can't multitask, and that's the nature of time dilation. But it's clearly connected to velocity. Without the velocity component, there's no clock broken. If the clock isn't being accelerated, or if it doesn't have velocity, it works just fine. Okay. So you can't pretend that you can jump to a frame that has velocity without first accelerating to get to that velocity. And the accelerating process, we know, is really destructive to the ship.
So again, does anybody have any evidence that it's actually gravity, independent of acceleration, that is causing time dilation?
Shape of your matter. It will break you. Alright, so that's probably enough of a test. Screen savers have some movie images, but I don't think you can see any of those. Let's see, lots of interesting features on here. Too many computers running. So that'll be enough of a video. I don't even know how it does that. Pick which screen you want. There's all kinds of little tricks. You move the mouse a certain way and it does that. I don't know what the tricks are. They don't tell you that. Hey, there it is. Somehow I did it again. So I think you just click on it.
Yeah, it's just trying to do this movement thing. You can do a movement thing that causes the windows to do that. Yeah.
No, I usually hate that kind of stuff.
And yeah, it's kind of neat. You
maybe it's just
choose what view you want, but I don't know what movement does it. I haven't figured it out yet. So, alright, so we're done with that. So I think this is the window. No, I guess this window would be the one that has the camera. Yeah, so you can have, the camera on all the windows. And this background image works pretty well as a gimmick. So the whole thing is not so bad. So I just got to plug in a better camera, and probably maybe I'll run this on the other computer like this. You know, I like this system. But anyway, we'll see how it goes. See what I do. See what I get around to. Much to do.